Hello, everyone. Hi, welcome to the next talk at Deploy. Today, we want to talk about how you can get the most out of your Kubernetes investment with a number of hopefully good networking best practices. My name is Timo Reimann. I'm a senior software engineer working at DO on the team that maintains the managed Kubernetes and container registry products.
Hi, everyone. I'm Varsha. I'm a software engineer on the containers team as well.
So the way we would like to structure this talk is in two parts with two different goals. The first part is about talking about the general networking features that DOKS provides to you. It's going to basically lay the foundation for how you can use DOKS from a networking perspective. We also want to talk about how you can make your DOKS-specific network more secure and isolate the network properly. And we want to go into what the key components are that provide the networking capabilities, because keeping those running is really important in DOKS. The second part is going to be about how to ingress external traffic, how to connect applications running outside your cluster with applications running inside the cluster. There are different routing strategies we want to go into, outline the different benefits and trade-offs, and then finally talk about networking pitfalls, which could impact the uptime and availability of your cluster. It's good to know about those. So for the first part, I'm going to hand it over to Varsha.
Thanks, Timo. So I'm going to be talking about some general networking practices and how you can leverage your resources for them. First up is virtual private clouds. VPCs are logical private networks for your DO resources like droplets, load balancers, and managed databases. So resources within your VPC communicate directly with each other, and they don't have to go through the public internet. And resources outside can only access the VPC at certain specific access points that you would have configured. Every DO account comes with a default subnet in all the regions that we provide, and you can also configure custom subnets. When you create a DOKS cluster, you can use the default subnet or your custom one, and all your control plane droplets, your worker node droplets, and load balancers that are brought up during the cluster lifecycle, they're automatically added to the VPC. And if your application uses a managed database, then those can be added to the VPC as well. VPCs ensure that all your DO resources or general cluster resources are secure. And the added benefit is that because these resources communicate directly, the data traffic between them is free of cost. Next up, we're going to talk about Cilium. Cilium is a CNI plugin that we provide exclusively on DOKS. So it offers you a very simple way of setting up network management on for your internal workloads in the cluster. Internally, Cilium uses eBPF, and eBPF provides you a way to some networking features like IP management inside the Linux kernel, which makes it fast. eBPF is also secure and quickly become a high-performance standard for cloud-native networking. It's open source and it's continuously improving. So from DOKS 119 onwards, new clusters that come up use Cilium in direct mode. This means that Cilium leverages the underlying network's capabilities to route traffic from your internal workloads in the cluster. So traffic from your internal workloads appear as if they're being emitted from a local process on the host. The advantage that this provides over the default VXLAN mode is that the packets emitted from your internal workloads need not be encapsulated with VXLAN MTU headers. So this reduces the overhead, and for certain kinds of application, this increases the network throughput. The Cilium installation comes with two components: Cilium agent and Cilium operator, and both of these are managed by DOKS. You don't have to do anything except monitor them to see that they're running all the time. Cilium agent is deployed as a daemon set, and it runs on every worker node. It usually accepts configuration via Kubernetes network policies and administers them on the workloads on that node. It also watches for pod lifecycle events like pod creation or pod termination because it needs to assign IP addresses to the pod. And unavailability of Cilium agent means that you can't schedule pods on that node. On the other hand, Cilium operator handles global cluster operations like IP allocation. And unavailability of Cilium operator means that you can have failures across the cluster. So always ensure that Cilium agent and Cilium operators are running up and running all the time. The next good practice to follow would be to use network policies. Generally, network policies allows you to configure access to certain parts of your application at an IP and port level. The Cilium network policy is just a custom resource definition that extends this basic functionality. It allows you to specify access via Kubernetes resources like services or DNS names and labels. And this can be used to isolate critical parts of your application. So here's a quick example of Cilium network policy. Here we have a MySQL database on the backend, and we want only the front-end service that we have configured to be talking to it. So we have the spec to say that, okay, MySQL is the service that we want to restrict access to. And then in Ingress, we specify what exactly can access MySQL. And that concludes part one, and Timo will go into how to route traffic into your cluster.
Cool. Thanks a lot, Varsha. So yeah, let's talk about how you can connect applications running outside your cluster with applications running inside your cluster. There are different approaches, but most of them involve the service type that most of you probably know. It's a way to group pods, and each service gets a service IP, and whenever you throw a packet at the service, it gets forwarded to the pods. There is a type field on each service, which you can set, and it influences how access is possible. The default value is cluster IP. That's what you get if you don't specify anything or specify it explicitly. It just means cluster internal traffic. So that's when you don't actually need external access. Then there's node port. When you set node port, then what Kubernetes does for you, it assigns a random high port, but the same high port on each of your worker nodes. So with that in mind, you can send traffic towards that specific high port on any worker node, and that traffic is then forwarded to the service and subsequently to your pods. And finally, there's load balancer, which is very similar to node port. It actually builds on top of node port from a technical perspective. And what it gives you is a DO load balancer being created and managed fully dynamically. So you do not have to worry about its lifecycle a lot. And then you can basically route either L4 or L7 traffic into your cluster. This is the way we usually recommend to ingress traffic because it provides for the highest flexibility and reliability. And we'll get into the details of that later. To mention two other alternatives, one is to use Ingress, which is a way to route traffic into your cluster based on L7. That usually means HTTP, and you can use HTTP-based rules like path and host-based rules. And Ingress can conveniently be combined with load balancer type services to get traffic to the Ingress pods. We'll also talk about that later. There's also a host port, which is a way to define a static host port on a pod. This is usually discouraged from in the community, mostly because you have to make sure that, that the ports of, say, two different pods do not collide. If they do, then one of your pods won't come up. So that's a bit more dangerous to operate. So here's a little diagram showing how the traffic flows if you use a service of type node port. Note that the diagram is technically not super accurate. Its primary purpose is to show how the traffic flows. So in this example, we have a cluster with 3 pods and fronted by a service, and we have 3 worker nodes. And because we use a service of type node port, that means we get this random high port, in this case 31337, associated on each of the worker nodes. What we also do in DOKS is we create and manage a firewall for you. And by default, that firewall doesn't allow any traffic to your worker nodes at all. But if you do use a service of type node port, then we automatically ensure that that specific port and just that port is opened up on the firewall. So let's say you have some kind of client, a customer sitting outside and sending traffic to one of your worker nodes. The IP address of your worker nodes on that port, then it goes through the firewall because the firewall has an allow rule. It goes into the worker nodes, and then by virtue of how a Kubernetes service works, gets routed to one of your pods. So this is essentially what a node port service does. 2 quick notes. Some customers, they use a node port, but only for VPC internal traffic because they say they have, let's say, a droplet part of the VPC, and they want that droplet to connect to your DOKS cluster. If you don't want or need access from the outside, but you do want to use a node port, you can set a specific service annotation, the firewall managed annotation, and set it to false. And that will cause a controller we run on the control plane to never open up the firewall. And the biggest caveat for node ports is probably, while node ports themselves are stable once assigned, worker node IP addresses are not. Worker node IP addresses can change when the worker droplets get replaced, which usually happens when you upgrade your cluster or when you recycle or replace a node to repair some kind of condition. So you should not hand out worker node IP addresses directly. What we normally recommend is to look at something like external DNS, which is an open project that allows you to have a DNS record getting updated continuously with changing worker node IP addresses. So that is something you can then hand out to the customer, to your client, the DNS record. So now let's look at what a service of type load balancer looks like. It's fairly similar because, again, load balancer builds on top of node port. So we get our node port again. But this time around, we have a load balancer sitting in front of your cluster. And the key benefit about that load balancer is that it's managed, and that means it gets updated automatically when something in your cluster changes, and specifically when your worker nodes change, because again, cluster upgrade, node replacement. We have a little controller running on the control plane called the Cloud Controller Manager, and it watches the nodes. And as they come, as they go, as they might become unhealthy because there might be an operational issue, it will send an update to the LB configuration. So that way your LB is always up to date. And in addition to forwarding the data packets, it also does health checks on its own. So you have yet another protection from failures that the load balancer might detect that the cluster might not yet detect. So this is why we normally recommend to use managed LBs, because they automatically adjust. In addition to that, managed LBs can be configured. Basically, mostly like vanilla DO-LBs can also be configured. But the way you do so is through annotations you add to the service object. There's a wide array of options available. We recommend to reach out to the product docs that we provide, where everything is exactly described. Basically, when you apply an annotation, change an annotation, this controller I mentioned will immediately pick up the change and reconfigure the LB. So it's available almost immediately. Some options have limited utility in Kubernetes DOKs, for instance, stickiness. So be mindful of that. The caveats are documented as well. And one key advice we like to give to us customers when you make a change to your annotations or the configuration of the managed LB in general, keep an eye out on Kubernetes events reported on those service objects, because all and any updates are reported through events. And that provides a way for you to identify any kinds of problems that may arise. Let's say one configuration was illegally defined, or there's a conflict between two configuration options. Those will be propagated as events, and it's a good way to look at those and act accordingly if there's an issue. So here's a quick example on what a managed LB configuration looks like. This shows just a regular service. This one is fronting an Nginx workload, and it has two ports identified, port 80 for HTTP traffic and port 443 for HTTPS traffic. And we have four DO-LB specific annotations defined here. The first one is about setting the default protocol to HTTP. Then we define port 443 as being the TLS port, so the DO-LB automatically sends HTTPS traffic to it. For HTTPS, of course, you need a certificate if you don't do pass-through. So we have a certificate ID referenced here. And because we never want unencrypted traffic to hit the LB, we also configure the LB to redirect HTTP to HTTPS. So that's one of many possible configurations you can have. So one configuration option on services worth talking about is external traffic policy. That field influences how requests are routed into your cluster and then onward from inside your cluster. The two possible values are cluster and local. If you use cluster, then what it does is that once an LB hits any node, any worker node of yours, it could be that there's another hop happening because you might have additional pods running on different worker nodes. And then Kubernetes might do another hop, even though on that first target node, there might already be a pod listening. So that's an extra hop you do. On the contrary, if you use local, then Kubernetes basically makes sure that the LB traffic always hits a node that hosts a pod and it stays on that node. So you don't have any extra hops incurred. It's worth mentioning that there are different trade-offs to both options, especially many Helm charts default to local, but it's actually good to know about the trade-offs. And there's an excellent blog post by Andrew Sai Kim that goes in depth into the different trade-offs. To give a too long didn't read is what you're basically choosing between is whether you want to have short request latency with local, but then you can also risk running imbalanced traffic, where some of your pods are getting more traffic than other pods. So this is a really good read that I would recommend to you. There are also two DOKS specific properties of using local. One is that any worker nodes that do not host any pods will be presented as unhealthy to the LB. And that tends to be confusing sometimes when customers use local and they check the DOLB page on the Cloud Control Interface webpage. And then you see a bunch of worker nodes unhealthy, when in fact they might be just turned unhealthy artificially by Kubernetes, because that's what it does for local, with the local setting in some cases. And the other thing to know is that in other clouds, other environments, local is a way to see the source IP address on the request, hitting the cluster, your applications directly. That's not the case for the OLBs, because the OLBs are terminating. So that means you will always see the source IP address of the LB. If you need to access the source IP of the actual client, then what you can do is you can use headers like X forwarded for HTTP, or use the proxy protocol. Both are options that you can enable or that are automatically enabled in case of X forwarded for on the DOLB. So here's a picture of what it looks like when you now use Ingress in combination with a DOLB. So again, fairly similar. Two things, I guess, are different. At the bottom, we have now not just one application, but three, basically hosting, in this example, 3 different web pages. And we have an Ingress controller running inside your cluster. So this time around, the traffic might go through by an LB, but it doesn't go directly to the target applications, but instead go to the Ingress controller. And then the Ingress controller has configuration in place, defined mostly by so-called Ingress objects that Kubernetes supports to decide who should get the traffic. So that, for instance, if the host header is foo.com, then the Ingress provider and controller will forward the traffic to the foo.com applications. So when would you use an Ingress over a pure DOLB? There are a few advantages of using Ingress. One is you have a wider range of L7 routing capabilities at your disposal. So for instance, I mentioned path and header-based routing. Many Ingress controllers and providers have more. Usually, Ingress providers are endpoint aware. So you might have seen that there are no services involved anymore in the routing path. Instead, Ingress controllers forward directly to the pods, to the endpoints, and that enables them to do more sophisticated features at times, like different retry algorithms. You may also want to centralize certain functionalities, like an API gateway to handle auth and proxy protocol at a single location. And sometimes customers just want to save money because an ADO-LB needs to map to exactly one application defined by one service. With Ingress, you can multiplex multiple applications over one single Ingress implementation, and thus one DO-LB ideally. On the downside, maintaining an Ingress controller is definitely more effort. They have varying levels of complexity, but you need to learn those. It's another application running inside your cluster that you need to maintain. But yeah, what you can usually do is combine those with the OLBs to forward at least TCP traffic to the Ingress controller.
Okay, to summarize part 1, always ensure that your DO resources are within a VPC so that they're isolated from outside resources. And the data traffic is obviously free, so that will be an added benefit. Ensure that your Cilium agent and operators are running properly at all the times. And isolate parts of your applications using network policies, and more specifically a Cilium network policy, so that your critical applications don't go down if something happens to other parts of your cluster. And then ensure that you run new TOX clusters on newer versions to maximize the network throughput, because Cilium is in direct mode here.
And to summarize part 2 about ingressing external traffic, we talked about the various service types that you can use. DOLBs is what we normally recommend because they can adjust to workload and node changes, especially IP changes, automatically. Node ports are sometimes useful as well, for instance, for VPC internal traffic, but please be aware of worker node IP changes. When you do use a managed DOLB, you have a number of configuration annotations you can set to influence the behavior of the load balancer. You should keep an eye on events when you make a change so that you get notified of any potential problems and can react accordingly. If you use external traffic policy, it's good to know about the trade-offs of cluster versus local. We talked about latency and request balancing and how droplets are displayed on the cloud control page and how source IP addresses are relayed. And for more advanced needs, you can always look into an Ingress controller and have all the Ingress features at your hand and potentially combine that with the DOLB. So that's all we had. We hope you found it useful. Thank you for listening.
Thanks. There are great upcoming talks coming. So we'll be on Discord to answer all your questions. And the questions that came up during the talk are already with us, and we'll be answering them one by one. Thank you. Bye.
Bye.